Good morning, good afternoon, good evening, ladies and gentlemen. And today we're going to be looking at trigonometric ratios of acute angles. Now, when you're looking at this all has to do with right angle triangles at first here. Okay? So what I'm going to first show you is how we would label these triangles. Now, of course, these are all right angle triangles. Okay? Now, the different words themselves, well, you have the hypotenuse, the opposite, and the adjacent. Now, the hypotenuse itself can easily be found because the hypotenuse is always going to be the angle that is directly across from the 90-degree angle. So this will always be the hypotenuse. Okay, so hypotenuse. Okay, now that doesn't change. What does change is depending on where the angle is, your other two sides will be labeled differently. Okay, so I'm going to show you what I mean by that. So let's say this is my x. Or, actually I don't like x. Let's go with theta. So this is our theta. So this is my unknown angle, or my known angle. Then looking directly across from it would be that, which means this is my opposite. Okay? And if that's the opposite, then right here would be the adjacent. Okay? Alright, now the hypotenuse, the other fun fact about the hypotenuse is that it is always belonging to the largest side. Okay? So what if now instead of my theta being here, so what if instead of my theta being here, it is somewhere else? Let's say it's here now. Well, if it's here now, you'll see that this changes your opposite position. Because now what's directly across is this. So this should now be my opposite, which means my adjacent is going to change to this side. Remember, adjacent just basically means right beside it. Okay? Now, I left you a third triangle here to play around with, putting your angle any place, and seeing how you can label these. Okay, so let's move on to the next slide where we start looking at the trigonometric ratios. Okay, so when you're talking about trigonometric ratios, this is when you start going into the old handy term of so, ka, toa. Okay, this should be a highly familiar term here. It's been looked at various years before. So basically means when you take the sine of theta, it's going to give you your opposite divided by your hypotenuse. Ka. Kamehameha. Yes, Dragon Ball. Ka, you're going to have cosine. Like this is an arrow. Cosine of theta. Well, the A is your adjacent, and your H is your hypotenuse. Okay, and then finally you got toa, which is tan of theta. It's always tan sine or cosine of the angle is equal to opposite over adjacent. Now, where you would use each one of these depends on the situation at hand. But before we look at that, let's also look at their inverse cases. Well, or as we call them, the reciprocal angles. Okay, so let's look at that on the next page here. So when you're looking at the reciprocal would basically be like this. So for sine, it would be cosecant, which is the same thing as saying 1 over sine theta, because remember, you're taking the reciprocal. Remember, this is the same thing as saying sine theta over 1. So the reciprocal means you are changing their positions. Now, if I'm changing those positions, this also means I'm changing these positions as well. So these should be hypotenuse over opposite. Okay. Now, let's try that out also with our cosine. So our cosine should be called secant. So secant of theta, not say theta here, sorry, which would be equal to, you guessed it, 1 over cosine of theta, which in turn is equal to these ones flipped. Hypotenuse over adjacent. Okay, and then finally we have here TOA, which should be called now cotangent of theta, which is the same thing as saying 1 over tan of theta, which is the same thing as flipping these again. So adjacent over hypotenuse. Okay, and those are what you call the reciprocal trigonometric ratios. Now, most calculators don't have the button for cosecant, secant, or cotangent. So when you wish to basically do this calculation, you need to actually do 1 divided by tan of theta, 1 divided by sine of theta, 1 divided by cosine of theta. That's what you want to do. So these are the ones that you should be focusing on when you're doing your calculations. So if you want to calculate cosecant of theta, you do 1 divided by sine of theta. Okay? So let's look at some examples. All right, ladies and gents, so let's take a look at this. So when we're doing these type of questions, these are the type of steps you always wish to carry out. So your steps here would be 1, label your sides. So the first thing you want to do is label your sides. You want to know which one, sorry about that, phone sounds silent. You want to label which one is your hypotenuse, which one's your opposite, and so on and so forth. Okay, so obviously this is the 90 degree here, which means here should be my hypotenuse. Okay, now depending on where your angle is, it could either be here or it could be here, but that changes which one is your opposite and which one is your hypotenuse. Okay, so I would have to add something specific to this question for you to narrow it down. So if I set down here, evaluate the 6 trig ratios for the following triangle for angle A. So I'm telling you this is your theta. Now if that's my theta, that means this is my opposite, this is my adjacent. Okay, so it's very important for you to label your steps first. Step 2, place them in the formulas. Now, when they say the 6 trigonometric ratios, what they basically mean is the sine, the cosine, the tan, the secant, the cosecant, and the cotangent. Okay, so we'll do some of them. I'm not going to do all of them here, but let's say you're talking about sine. So sine of theta, I know is opposite over hypotenuse, which I also know is, what's my opposite? 3. What's my hypotenuse? 5. Cosecant of theta is hypotenuse over opposite, which is the same thing as saying 5 over 3. Okay? So I want you guys to try out, I want you to pause the video at this point, and I want you to try out the tangent, the cotangent, the secant, and the cosine. Okay, once you're ready for that, we're going to move on to the next example. Okay, so continuing on, let's take a look at these type of questions. So when you want to find the reciprocal, this is now going to turn into 1 over sine of theta. And of course, this is cosecant. All right. And if it's 1 divided by sine of theta, what is sine of theta? This. So it's 1 divided by 2 over 3. Now remember, whenever you divide by a fraction, it's the same thing as multiplying by the reciprocal of the bottom, which in this case will then give you 3 over 2. Okay? Now, some of you will probably notice that you could have probably just at the beginning done the reciprocal, which is true, you could. But this is the reasoning behind why you could do that. Okay? So I want you to take a quick pause of the video and try out B yourselves. Okay, welcome back. If you're not pausing the video, this would seem oddly hilarious or odd. So once again, you have 1 over tan of theta, which is equal to 1 over 5 over 7, which if we're following our steps, is 1 times 7 over 5, which is 7 over 5. Okay? Okay, so at this point, how then would I calculate this using my calculator? So let's look at something else here. So let's say I gave you secant of 23 degrees. Well, once again, your calculator does not have a secant button. So to do that, you would have to transform this in your calculator and turn it into 1 divided by, well, what is secant? Secant is 1 divided by cosine of theta. Theta in this case is 23 degrees. Okay, so you do 1 divided by 23 degrees, which if your calculator is correctly on the right mode, you should get approximately 1.09. Okay, so try out cosecant of 87 degrees yourselves. Alright, so if you tried it out, you should be able to transform this into 1 over sine of theta, which is 1 over sine of 87, which is 1.00 approximately. Okay. Now, how would I then find out my theta if I'm missing it? So let's say I'm now having here cotangent of theta is equal to 1.248. Okay. So at this point here, what you're going to be doing is your tangent is going to change. So I know that this is going to be changing here into 1 over tan theta. And if that's 1 over tan theta, how would I then go about doing this? So 1 over tan theta is equal to 1.2458. I can't solve for it while tan theta is in my denominator. So what I need to do, just like we normally do whenever we see a fraction, is we multiply both sides by the denominator. Okay, we'll continue this here, which will get rid of the tan thetas here. So I'm going to have here 1 is equal to 1.2458 tan theta. Once again, I'm still trying to get it by itself, so I need to divide both sides by 1.2458. Which will get rid of this, leaving me with tan of theta is equal to 1 divided by 1.2458. The second you have it at this stage, so I'm going to rewrite it over here just so we can have some room here. So tan theta is now equal to 1 over 1.2458. To get theta by itself, you need to take the tan inverse of this number. Okay, now that's a button in your calculator. If you do the second button, usually most of the time, or shift on some calculators and press tan, it will turn into tan of minus 1. So you're doing tan of minus 1 of this, so theta should be approximately 39 degrees. And don't forget your degree symbol there. Okay, so we're just going to look at this in a little bit more detail with another example, just to make sure people fully understand this. Sorry, the last page got a little bit cluttered, so I'm making a new page here so we can look at it in all of its glory here. I'm going to write down the steps here in the corner. If you already feel that you can do this, by all means, pause the video, try it yourself first, and see if you're correct. Okay, so your steps. First one, transform into reciprocal. So the secant of theta should turn into 1 over cosine of theta. Then you want to multiply both sides by your bottom. So I'm going to multiply both sides here by cosine of theta. Okay. Finally, you want to divide both sides. By the coefficient, so in this case you're dividing both sides by 1.632. And then finally you're going to have cosine of theta is equal to 1 over 1.632. And to get theta by itself, you finally in your last step take the cosine inverse, or whichever ratio you're using, of the numbers. So I'm going to take the cosine inverse of 1 over 1.632, which should give you approximately 52 degrees. All right. Now, if we look above here, what do we notice about this answer here and this? So what am I noticing about here and here? Well, I'm noticing that in the secant, it's just a normal number. And I guess you can argue it's kind of 1.632 over 1. Maybe that helps people notice this. And over here, we have 1 divided by 1.632. So a little shortcut, if you wanted to avoid doing all these steps here, is quite simply going from here to here. So you could skip these 3 steps if you fully understand what you're doing here, because essentially what your cosine theta is the reciprocal of what your secant is, and vice versa. And that should always work, and that should also save you some time. And that's all we need to say for this kind of lesson, so I hope this has answered any of your questions and concerns, and please let me know if you need any help with this. Thank you, and have a good day.